We are skipping the fluff today and reverse engineering the absolute perfect physics exam answer, specifically for Cambridge IGCSE Physics 0625. We're starting from the perfect final answer and working backwards. No generic study advice here, guys, just the exact, ruthless strategy that protects your grade boundaries when that exam timer is ticking down. But before I teach you anything, look at the calculation on screen right now. Make your choice between A, B, or C. A motor transfers 100 joules of electrical energy, doing 70 joules of useful work. What's its efficiency? Is it A, 70%, B, 0.7, or C, both A and B? Lock in your answer right now, literally right now, because your grade boundary might actually depend on how you respond to seemingly simple questions exactly like this. So what's wild about this is that a student might logically think they've nailed it, but writing, the motor is 70 efficient because 70 out of 100 is used, actually scores a brutal 0 marks in Cambridge physics. Why? Well, because the answer completely lacks a percentage sign or hasn't been expressed as a proper decimal ratio. To an examiner, 70 on its own is just a meaningless number in this context. You had the right numbers, sure, but you used the completely wrong exam language.
And this brings us to a pretty massive realization. Ordinary revision fails because it completely ignores these painful, super common mistakes that drain your marks like a leaky bucket. You can memorize the entire textbook, but if you step into that exam hall and make graph axis errors or round your numbers halfway through a calculation or just give vague explanations, your knowledge simply won't translate to your final grade.
So the absolutely crucial takeaway here? A perfect calculation with a missing or incorrect unit instantly drops you to a big, fat 0 for the final answer mark. Examiners are ruthless about this, guys. A number without a unit or a ratio missing its percentage sign just screams a lack of scientific precision. It's honestly the absolute easiest way to bleed marks on a paper you otherwise understand perfectly.
Okay, so how do we fix this? Let's move on to the physics mark framework.
We are going to implement a foolproof system to guarantee those maximum marks. Say hello to the CERE framework. This is your quick win for structuring literally every single answer. It stands for concept, evidence, scientific reasoning, and examiner wording. Whenever you face a structured question, you state the core concept, you back it up with evidence from the data, you apply reasoning to connect them, and then you wrap the whole thing in precise examiner wording. It's basically the anatomical structure of a top-band mark scheme.
All right, let's actually apply this framework directly to a core topic like energy.
To completely nail the concept step of our framework, you've got to clearly distinguish your energy stores from your energy transfers. Look at the comparison here. Stores are where energy is kept. Think of a battery's chemical store or a raised object's gravitational potential store. Transfers, on the other hand, are how energy moves between those stores, like heating, electrical pathways, or radiation. Mixing these up is a classic trap. You don't have an electrical store of energy, right? Electricity is the transfer mechanism.
Then we hit the reasoning step. The law of conservation of energy states that energy cannot be created or destroyed, it can only be transferred between stores. Now, this definition is the absolute bedrock of your scientific reasoning. If your answer even slightly implies that energy just magically vanished from the universe, the examiner is instantly reaching for their red pen.
Now, in just a moment, I'm going to show you a hidden examiner clue that changes your calculation completely. But first, do you actually know how to build the perfect answer? You've got to stick with me here because leaving now means missing a critical examiner clue about work and power that catches nearly everyone out under exam pressure. We have to secure this foundation first. So let's take a look at flawed versus perfect answers. Let's see how our CERE framework transforms a failing response into a top-band masterpiece. A flawed answer will say something like, energy is lost as heat. And honestly, it feels correct, right? But it directly violates the conservation law. Energy is never just lost. Notice how the perfect answer applies our framework instead. Thermal energy is transferred to the surroundings, dissipating the energy store. See the difference? It uses exam-safe wording, correct terminology, and shows a much deeper understanding of the actual concept. This demonstrates exactly what examiners are actively hunting for on your paper. A top-band answer is always going to include correct terminology. It explicitly states the equation before doing anything else. It substitutes values with their units clearly written out, and it strictly fulfills specific command words like describe, explain, or calculate. All right, it's time to dive into that hidden examiner clue I promised you regarding work and power calculations.
The crucial clue that changes absolutely everything is hidden right there in the variables. Read this carefully. Power requires time in seconds, not minutes. Power is the rate of doing work, right? It's measured in watts, which is joules per second. Failing to convert your time to seconds ruins the entire equation. And guess what? Examiners will purposely give you time in minutes or hours just to set this exact trap. Let's test this right now with a spot the error challenge. Take a look at this calculation and try to identify the devastating mistake. The student wrote, power equals 500 joules divided by 2 minutes equals 250 watts. Now, under the stress of a ticking clock, plugging 500 divided by 2 into your calculator feels super productive, but it is completely 100% wrong.
Here is the proper examiner-style correction broken down step by step for you. Step 1, identify your variables from the text. Step 2, convert those units immediately. 2 minutes times 60 equals 120 seconds. Step 3, now you can calculate. 500 joules divided by 120 seconds. And finally, step 4, the correct final answer is 4.17 watts. This proves exactly why rounding too early or just using the wrong variables completely destroys your score. Before we wrap up this explainer, we really need a system to bulletproof these answers. Let's talk about the final check protocol. You've done the hard work, you've applied the framework, now you have to protect your investment. I want you to run every single answer through this exact checklist to lock in those final method marks. Number 1, are the units included? Number 2, are your significant figures correct? Number 3, if it's a graph, are the scales accurate and actually linear? And number 4, is the answer physically reasonable? I mean, a motor outputting more energy than it took in is literally impossible. So if you see that, you'd better recheck your math.
So, what is your next physics challenge?
You now have the rock-solid framework for energy. You know the traps, the unit conversions, and the exact examiner wording. But guys, the exam doesn't stop there. What happens when this exact framework is paired with the crazy complexities of thermal physics? What happens when energy transfers start involving specific heat capacity, latent heat, and complex particle motion? This leaves us with a massive, unresolved problem regarding the very next hardest physics skill you'll face.
Which is exactly why we solved this in our last 7 days revision map. Watching that explainer is the mandatory next step to ensure you don't lose all the marks we just secured today when the exam suddenly pivots from basic energy into advanced thermodynamics. You absolutely need to see how the framework adapts to those harder questions.
So, hit that explainer on your screen right now to seamlessly bridge the gap to thermal physics. And subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Before you go, ask yourself, will your hard-earned energy marks melt away under the pressure, or are you ready to master the heat? I'll see you in the next explainer.